Hello everyone. I found this article in Amazon Startup Blog which explains the availability, how to achieve availability on AWS, or it could be any platform for a simple application. It explains nicely how using a simple web application stack, how the availability is calculated and how can you improve your availability and the scalability of your system. So I'll share this link in the description. High availability for mere mortals. It was written by Slavik Dimitrovic. I hope I'm pronouncing it correctly. He's a solution architect at AWS. So let's get into it. So this article explains what are the availability requirements and how do you think about it when you're developing a system. So most probably you shouldn't be thinking it from the beginning. So when you're building an application, high availability into a system early on may slow things down and lead to over engineering. Yet we should consider eventual desired level of availability and ensure that we can grow our system into it when the time comes. So what this means is that when you're developing a new product or an application, think about the features and how you can improve your application, because in the beginning you will not know what are the features that your users will demand, and then you should be able to tweak your application to cater the user's demand instead of thinking about the infrastructure aspects. So it's better to keep your application simple in the beginning. When we start a new system, it makes sense to keep things simple. At the early stage, any product, you don't really know whether it's even going to fly. Speed of iteration, ability to quickly respond to feedback is the most important attribute of your system. The simplest way for me to start would be keeping everything on a single box. So just deploy your application into a single server, VPS, or an EC2 instance if you're on AWS. The main issue with this approach are, of course, scale and availability. So when you limit your application into a single box, if that server fails, your whole application goes down. None of your users will be able to access your system. So as the first step, this article shows step by step how do you go from single box to achieve your desired amount of availability. So the first step is to split your application into tiers. If you have a .NET application or a JavaScript or Node.js or any server-side application, you should split this into two layers. It could be a web layer which could serve API calls, or it could be serving HTML pages or static content. Every tier can be placed on its own box of the appropriate size and cost. We can choose bigger, better boxes with multiple layers of hardware redundancy, or our database servers, and cheaper commodity grade hardware for our web and application servers. Well, what this means is that, so let's assume that your system needs 99.5 availability, desired SLA, service level agreement. That means your system has to up and running for 99.5. You can do this calculation from this website, uptime.is. Let's say you wanted to have 99.5 availability, which means in a year you can have 1 day and 19 hours, 49 minutes downtime. This much you can afford to have. So this could be unplanned outage, your release times, your service goes down or network goes down, anything could be that sort. Your application will need to not be available. Yeah, it says here it's allowed to be down no more than 44 hours in any given 12-month period. So in this case, EC2 provides in AWS or in any server, any single server, you can assume that it provides 90% of uptime per year. So 90% is like, how much is very less. It's bad, it's not that good. So 90% is daily 2 hours, your system will be down. Yearly is 36 days. It'll be like more than 1 month your system will be down. Nobody wants a system like that, right? So if you have your application into one box, and then if you have your server with higher availability server, 99.99% availability, and your app server, so now you have to split your application. So this is another engineering problem, because now you have to have some sort of a remote call. It could be a remote procedure call, or it could be API call, or JSON or REST API call, or gRPC, or it could be different protocol, HTTP or something. You have to have a remote call from your web server, from your web tier to application tier. Right now you have 90% availability on the web server and 90% on the app server, 99 on the DB server, and this is how it calculates. So 0.9 into 0.9 and into 0.99 equals 8019, which means 80.2% availability if you go in this model. Now, so we are not achieving our 99.5, we are way below, it's 80%, right? So 80% is like how much? You will be having 2 months downtime. Yeah, so 70, so it's 73 days. It's almost like 3 months downtime you're going to have. So this is not good. Okay, now let's introduce redundancy. In the first glance, we are not doing too well. Availability of the whole system is way too below our desired uptime, and even below the availability of any single component of the system. However, by splitting the system into tiers and by pushing the state to the database tier, we have set the stage of solving some of the problems of availability. So this is just the beginning. So you are in the correct path to solve the availability problem. The simple way to increase availability is by adding redundancy, which is much easier to do with the stateless parts of the system. So it's very important to identify what is stateless means. So there are different types of applications: stateless applications and stateful applications. So stateless means your application doesn't remember the users who are connected to the system. For example, if I logged in and I go to a different page, the application won't remember me, so that application won't work. So it's very difficult for you to have this type of application and give a good user experience. So you have to keep some sort of state in somewhere. So the point is that your application should be developed in such a way that you can save this state. For example, your server has to keep some information, your username or your profile information, at least the state that you are already logged in. So when you go to a different page, you don't need to prove you that already logged in, so your server knows it. So the thing is that you cannot keep it in the web server or in the application server, because if the server goes down, your user's state will be lost. So in that case, you have to persist your state on the database or in a different place, right? So then only you can achieve this scalability requirements or the availability requirements. Right now we are bringing one more web server. Now we have two web servers in the web layer, 90% availability of each, which turns into 0.99. So okay, 1 minus 0.9 means 0.1. So 0.1 into 0.1 minus 1, so which means 0.99. And then your app server is 90%, this is 99%. So 0.99 into 0.9 into 0.99, 0.8821. So still you're 88.2% available. So this is better than previously. By adding one server, we increased availability by 8%. Not bad, but still we are below the desired amount of availability. So now let's try to add one more web server and see how it improves. So now we have 3 web servers in the web layer, each 90% availability. Now if we apply the same formula, we get 0.999 on the web layer, 90% on the app layer. 99 on the DB layer. So total comes to 89.0%. So the cost of this tier grows linearly with every server, but availability grows logarithmically. So which means the cost increase linearly, but the availability doesn't improve as much as you invest. Eventually you will reach point of diminishing returns, which means you are keep on investing but you're not getting any returns out of it, right? So this is not good. Now we are going to expand redundancy to other tiers. So we are going to scale the app server layer as well. Now we have 3 servers on the web, 3 servers on the app. So each layer we get 0.999 availability, which means 99. Total we get 98.8%. Still we are below our desired 99.5, right? So now what we can do? So the last step we can do is scale the database layer. But doing this is not simple because your application should be able to so basically what we are doing is we are keeping one master node, one master database which takes all the write operations, and 2 different read replicas which take all the read transactions. So your application should be intelligent enough to send the write traffic to the master node and send read traffic to the read replica. So now here we get 999 here, 0.999, and in the database it's 69. So total will be 0.9980, which means 99.8. Okay, now we have achieved the desired amount of availability. However, now we have to think, what if the whole data center goes down? So for example, let's now take this one step further and take a look at another part of the stack that has been assumed all along but never brought into light: the data center that hosts it. Should it go down due to power outage, internet connectivity issues, fire, or natural disaster, your entire stack will become inaccessible, rendering all investments of time and money that we made into multi-tier redundancy stack will become useless, right? So if the whole thing goes down, all your availability go into a toss, so you won't be able to access it. Now let's say you host this in a tier 4 data center. You pay a lot of money. So tier 4 data center gives you 99.995% guaranteed availability, but this is just in one data center. So if in case natural disaster your data center goes down, all of your application will be down. So now how do you solve this problem? Maybe you have to host your application in 2 different geographical locations, in 2 different data centers which are in different locations, so you will not get the same natural disaster or the power outage in both the data centers. So multiple data centers. So what about the latency? What about maintenance overhead? So all these and other questions may occur in your mind when you read the last suggestion, and under normal circumstances you would be correct. In order for this approach to be successful and cost effective, we need data centers that are built for high reliability so that nothing short of a natural disaster bring one down, located close to one another, and connected via low latency high bandwidth links to ensure low latency between the facilities, located far enough from each other that a single natural disaster cannot bring all of them down at the same time. So this sounds like AWS availability zone. So now this brings us to AWS availability zones, and how do we host the same stack that we are discussing on the above in the AWS availability zones. So we will have 2 availability zones and deploy our application into 2 availability zones at the same time. So we have 2 web servers on and 2 app servers on one availability zone, and 1 master database and 1 read replica. Also in the other availability zone we have 2 web servers, 2 app servers, and 2 replicas. So your application should send all the read traffics to availability zone A and the read traffics to the other read replicas of availability zone A and zone B. You can improve this architecture a little bit more by adding AWS S3 hosting static web content. your images or HTML files, JavaScript, things like that. And also you can use AWS CloudFront, which is the content delivery network of AWS, to improve user experience. So your content will be cached near to the user's location, and they don't want to hit the servers to get those resources. And also you can use AWS auto scaling. So auto scaling means that when one server goes, you can define how many servers should run at a peak level, or how long it could scale out, and how much it could be scaled down when the traffic is low. Based on your traffic, the AWS will spin up new servers or stop these servers if there is no sufficient traffic. So that is AWS auto scaling. And this is a typical architecture on AWS infrastructure when we host this same application. We have Route 53 for DNS, and then we have CloudFront for content delivery. You can have S3 to serve static content, and then load balancer. You have two availability zones, and each zone you have app servers, two web servers, two app servers, and the database. This also discuss something a little bit about scalability, and give some basic idea what is the scalability aspect that we should be thinking of and should know about. When scaling a component of a system, two approaches can be used: getting a bigger box, also known as scaling up, or vertical scaling. The other option is getting more boxes, also known as scaling out or horizontal scaling. Vertical scaling may be easier from operational standpoint, but has two major limitations. First, bigger boxes tend to get more expensive faster, and then the additional scale they provide. Second, there is a limit how big of a box you can get. So there is always a limitation that you can scale up. Horizontal scaling offers more room to grow and better cost efficiency, but introducing additional level of complexity require higher level of operational maturity and higher degree of automation. So now the problem is that when you have more servers, you have to have some automation, like build automation, deployment automation, to deploy your application at the same time for multiple servers. You cannot do it manually, and also your development has to be efficient in that way. However, in order to make this scaling solution even more cost effective, we need the ability to add and remove nodes dynamically in response to fluctuation in traffic. So that's what we discussed about auto scaling. By hosting your stack on AWS, you can achieve highest level of availability, including data center redundancy, as well as dynamic horizontal scaling in an easy and cost effective way. The summary of the article is: split a system into tiers, allow managing and availability and scalability of each tier independently. Adding parallel nodes to a tier component increase overall availability of that tier and the system as a whole. The increase is logarithmic, however, which leads to diminishing returns. Availability of the whole system cannot be greater than that of its least available component or the tier. Data center availability should be considered as part of total systems availability. So ultimately, your availability becomes your data center's availability. So that is the reason you should have multiple data centers. AWS makes it very easy to build highly redundant multi-data center systems, reaching several nines of availability that also supports dynamic horizontal scalability. Adding redundancy to the data tier becomes necessary once it becomes the availability bottleneck. Doing so, however, brings it with new challenges too. So there is another part which I will cover in the next video. That's it for this article and for the video. Thank you very much.